Hey there, fellow scientists. Today we will be talking about static and current electricity. So let's get right into it. Let's start off with static electricity. Well, static electricity is the build of electrical charges on an object's surface. Static means that the charges stay in one area and don't move around. The charge is created when two objects rub against each other. This causes the electrons to move from one object to another. This would make one object have a positive charge while the surface of the other object would have a negative charge. And rubbing the two objects together faster would create a larger charge. This is because more electrons would get transported to the object's surface. And when the items have different charges from each other, they would attract. This is why when you rub a balloon on your head and you move the balloon away, your hair stands up. This is because they have different charges which attract. But on the other hand, if two surfaces have the same charge, they would push away from each other. Like when you put the positive side of a magnet with another positive side of the other magnet, they would repel from each other. And these attracting and repelling methods are used in quite a few jobs. The power of static electricity has also created jobs just for its use, such as air pollution control, xerography, and car painting. All of these jobs require static electricity. Air pollution control stations apply static charges to the particles of dirt in the air. And from there, the charged particles get collected on a metal sheet which is called electrostatic precipitators. And factories actually use these a lot to reduce their amount of pollution. When the smoke gets charged, they pass a wall with the opposite charge, causing the smoke particles to cling to the wall. Now that we talked about how it's used in air pollution control, now let's talk about how static electricity is used in xerography. Well, Xerox, the printer company, actually uses static electricity to print a page. The printer's ink gets charged, which makes it stick to the areas of the paper which want to be printed, which is the opposite charge. So that's how it's used in that printer company. Now let's talk about how it's used in car painting. Well, most vehicle painters actually use static electricity to paint the cars. The paint they use is given an electrical charge. And when they start to spray a thin layer of it into a booth where the car is parked, the charged particles get attracted to the car and start to stick onto it. When the paint dries, it becomes more spread out, causing it to be smooth. So see, static electricity isn't just that shock you get when you touch your doorknob, it's much more than that. Like a spark of it may be nothing, but millions of them combined would be very dangerous. Such as lightning, which is a very powerful source of static electricity. But if you really think about it, would weather affect its power? And the answer is yes, it actually does. Static electricity tends to occur more and be more powerful on dry days. Days when the humidity levels are really low and dry, static electricity would be very powerful and would occur a lot more. That's why whenever you take your clothes out of the dryer, you get shocked by your clothes, because they just came out of a really dry area, hence its name. But isn't static electricity just a force of attraction? How do sparks form from it then? Well, this happens when there's a large amount of positive charges on one surface and a large amount of negative charges on the other surface. Since there's a large amount of the charges, the force of attraction would be so strong that the electrons would jump the space in between each other. And this would create a lot of heat in the air, which would attract even more electrons and more and more and more, which would create even more heat. Just enough to create a light in the air. The light stays for a fraction of a second, and that is called a spark. And this is actually how lightning is also created, just on a much larger scale with much larger voltages. So static electricity isn't just rubbing a balloon on your head, it's much more than that. But anyways, let's move on to current electricity. An electrical current is the flow of an electrical charge. And in a circuit, these charges are carried by electrons flowing through a wire. And for those of you who didn't know, circuits are the paths for current to flow through. The course of a circuit begins and ends at the same point, which means a circuit must be in the shape of a loop. Otherwise, it wouldn't be a circuit. A basic circuit must contain two parts, the battery and the power consumer, which in this case is a lamp. So the circuit lets the current move from the battery towards the lamp and then back to the battery where it started from. Currents are able to move in circuits due to its voltage source. And circuits can be broken down into three simple components: the voltage source, load, and conductive path. The voltage source is what makes the current move in the circuit. And the load is what takes in the power, such as a light bulb. And finally, the conductive path is the path that the current moves through. And without any of these three components, there would be no circuit. But what we were just talking about is a closed circuit. What if a circuit is disconnected and not forming a loop? Well, that would be called an open circuit. Since the loop is disconnected in open circuits, a current wouldn't be able to flow and generate electricity. Because the current has to start from the battery, then goes to the power consumer and must go back to the battery, but in an open circuit, it cannot go back, which creates no electricity. But closed circuits, on the other hand, can have currents flow since they're connected. But those aren't the only circuits, there are a few more, such as a short circuit. These are circuits with more than one path for the current to flow through. However, these types of circuits are highly dangerous due to the multiple currents flowing through one circuit at the same time, which means it could cause the battery to explode due to the intensity levels. And by the way, there's something called a resistance in a circuit. The resistance in a circuit controls the movement of the current by its friction. Just thought I'd tell you that. So let's explain how a circuit really works step by step in a diagram. So here, as you can see, we have a full circuit. First, we powered on the voltage source or battery. And the amount of voltage power we needed to power this light was 3. We did this by turning up the energy level to where it says 3. And then from there, the current travels from the battery to the power source, which is the light. So that's what current electricity is all about. So now let's talk about static electricity versus current electricity. Well, static electricity is formed by the buildup of charges on object surfaces when rubbed with another object. Current electricity is created by batteries and conductors. And by the way, a conductor allows a current to move freely, while an insulator controls currents and does the exact opposite of what a conductor does. Static electricity is usually uncontrolled, while current electricity is usually controlled. So that's static electricity versus current electricity. And that's it overall, so I hope you enjoyed and have a good day.